Electrical bonding jumpers are essential for reinforced concrete footings to ensure electrical continuity throughout the structure. This bonding helps prevent the buildup of static electricity and provides a reliable path for fault currents to ground, enhancing safety and protecting electrical systems. Typically, the electrical contractor is responsible for installing these bonding jumpers and providing a bonding certificate to verify compliance. However, specific requirements can vary based on local building codes and regulations. In reinforced concrete footings, electrical bonding is crucial to electrically connect all sections, facilitating the free flow of current. This ensures proper grounding of the building and minimizes the risk of electrical hazards. When an inspector identifies a requirement for bond jumpers between sections of a footing and requests a bonding certificate for each section, it indicates the need to verify compliance with local electrical codes. The fact that the engineer and building official inspected each footing section suggests that the bonding requirement might not have been adequately addressed during those initial inspections. To address this situation, firstly, consult with the local building authority to verify the specific bonding requirements for reinforced concrete footings in the area. This consultation ensures alignment with the latest codes and standards. Secondly, coordinate with the electrical contractor to clarify responsibilities for installing the bond jumpers and providing the bonding certificate. Clear communication prevents misunderstandings and ensures timely completion of the work. Thirdly, if the electrical contractor is responsible, instruct them to install the necessary bond jumpers and provide a detailed bonding certificate. The certificate should document the bonding process and confirm compliance with all relevant codes. Fourthly, submit the completed bonding certificate to the inspector for approval. This step is crucial for demonstrating compliance and obtaining final approval for the electrical installation. In the context of electrical installations, several key concepts and requirements from the National Electrical Code, or NEC, are relevant. Article 250 of the NEC covers grounding and bonding, providing detailed guidelines on how to establish a safe and effective grounding system. Section 250.50 addresses grounding electrode systems, specifying the requirements for grounding electrodes such as metal underground water pipes, metal frames of buildings, and concrete encased electrodes, also known as UFA-grounds. Section 250.52 details the specific requirements for different types of grounding electrodes, ensuring they meet minimum standards for effectiveness. Section 250.64 outlines the requirements for grounding electrode conductors, specifying the size and installation methods to ensure a low impedance path to ground. Section 250.104 covers bonding of metal water piping and other metal objects, ensuring that they are properly bonded to the grounding system to prevent voltage differences and electrical shock hazards. When installing grounding and bonding systems, it is essential to use appropriate materials and methods to ensure long-term reliability and effectiveness. Ground clamps and connectors must be listed for direct burial and compatible with the materials they connect. For example, using copper connectors on aluminum conductors can lead to corrosion and failure. The size of grounding and bonding conductors is also critical. NEC Table 250.122 provides guidelines for sizing equipment grounding conductors based on the rating of the overcurrent protection device. This table ensures that the grounding conductor is large enough to safely carry fault current back to the source. In concrete encased electrodes, the NEC requires a minimum of 20 feet of bare copper conductor not smaller than number 4 AWG. This conductor must be encased within at least 2 inches of concrete and located near the bottom of the footing or foundation. The purpose of the concrete encased electrode is to provide a reliable, low impedance ground path that is resistant to corrosion and physical damage. When connecting to reinforcing steel or rebar, the connection must be made with listed connectors suitable for direct burial in concrete. These connectors ensure a secure and corrosion-resistant connection between the grounding conductor and the rebar. Regular inspections and maintenance are essential to ensure the continued effectiveness of grounding and bonding systems. Visual inspections can identify signs of corrosion, loose connections, or physical damage. Electrical testing, such as ground resistance testing, can verify the integrity of the grounding system and identify potential problems. When performing ground resistance testing, it is important to follow established procedures and use calibrated equipment. The fall of potential method is commonly used to measure ground resistance, involving the use of auxiliary electrodes to establish a test current and measure the voltage drop. The measured resistance should be compared to acceptable values, typically 25 ohms or less, as recommended by the NEC. If the measured resistance is higher than the acceptable value, it indicates a problem with the grounding system that needs to be addressed. This may involve adding additional grounding electrodes, improving connections, or replacing damaged components. In addition to grounding electrodes, bonding jumpers are used to connect different metal parts of the electrical system together, ensuring that they are at the same electrical potential. This helps to prevent voltage differences and electrical shock hazards. Bonding jumpers are required for metal water piping, metal gas piping, metal conduit, and other metal enclosures. The size of bonding jumpers is determined by NEC Table 250.102, based on the size of the service entrance conductors. Bonding jumpers must be installed in a manner that provides a low impedance path for fault current. This typically involves using short, direct connections with minimal bends or splices. The connections must be made with listed connectors that are suitable for the materials being connected. When bonding metal water piping, the bonding jumper must be connected within 5 feet of the point where the water pipe enters the building. This ensures that the entire water piping system is effectively bonded to the grounding system. In addition to bonding metal water piping, it is also important to bond metal gas piping to the grounding system. This helps to prevent the buildup of static electricity and reduces the risk of gas ignition. The bonding jumper for gas piping must be connected upstream of any insulated joints or unions. When installing bonding jumpers in concrete footings, it is important to protect the jumpers from physical damage and corrosion. This may involve encasing the jumpers in conduit or using corrosion-resistant materials. The jumpers must be securely connected to the reinforcing steel with listed connectors. Regular inspections of bonding jumpers are essential to ensure that they are in good condition and properly connected. Any damaged or corroded jumper should be replaced immediately. Electrical safety is paramount when working with grounding and bonding systems. Always to energize electrical circuits before working on them and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Follow lockout/tag-up procedures to prevent accidental re-energization of circuits. Only qualified and trained personnel should perform electrical work. Proper grounding and bonding are essential for protecting people and property from electrical hazards. By following the guidelines in the NEC and using appropriate materials and methods, electrical systems can be made safe and reliable. Regular inspections and maintenance are crucial for ensuring the continued effectiveness of grounding and bonding systems. In summary, the electrical contractor is typically responsible for installing electrical bonding jumpers and providing a bonding certificate, but specific requirements vary by local codes. Bonding is essential for reinforced concrete footings to ensure electrical continuity, prevent static electricity, and ensure proper grounding. The inspector's request for bond jumpers between sections and a bonding certificate highlights the need to verify code compliance. Given that the engineer and building official inspected each footing section, it's important to address why the bonding requirement wasn't initially addressed. Recommended steps include firstly consulting with the local building authority to confirm specific bonding requirements. Secondly, coordinate with the electrical contractor to determine responsibility for installing jumpers and providing the certificate. Thirdly, instruct the contractor to install necessary bond jumpers and provide a bonding certificate if they are responsible. Fourthly, submit the certificate to the inspector for approval, ensuring compliance and project sign-off. By addressing these points, you ensure a safe and code-compliant electrical installation for the new school. The NEC provides comprehensive guidelines for grounding and bonding, emphasizing the importance of a low-impedance path to ground. Understanding and adhering to these requirements is crucial for electrical safety and system reliability.